Okay, this is Math 105, Section 110, Part A. We're going to start by talking about the slope of a line. So when we talk about a slope of a line, we're talking about how steep that line is. And we look at it as a ratio of rise to run. So we can look at that as slope equals rise over run. In other words, rise would be the up and down, okay, and then run would be the back and forth, okay. So we can say that the rise is the corresponding change in the y-coordinate between any 2 points on the line, okay. If we look at the change in y, that would be this vertical change here, okay. And then so that would be the up and down here, okay, so that's the rise. And then the run is the change in the x-coordinate, okay. So that would be the back and forth part, okay. So that's this thing here, back and forth, okay. So we can look at that as rise, how steep, how far up and down we've gone, over run, how far we've gone back and forth as a slope. Okay, so in algebraic terms, we use m as the slope of a line, okay, and it passes through. Let's say it passes through 2 points. One is a, and that's x1, y1, and one b is x. The other point is b, which is x2, y2. The slope is the rise or run, so that's going to be the change in y over change in x. Okay, and sometimes we use this delta notation. This delta is a triangle, but that would be, we say change in y, delta y, over change in x, delta x. So that's another way to write that. Okay. Now, we talk about a vertical line, we don't talk about slope because there is no change in x for a vertical line. So we can say the slope of a vertical line is not defined. Okay. So in terms of the 2 points, x1, y1, and x2, y2, the slope would be y2 minus y1 over x2 minus x1. Okay. And also we can say the slope is independent of which 2 points are chosen on the line. So it can be any 2 points, and we'll always get the same slope. So we can use any 2 points, and we'll get the same m. So here we see, here's a point x1, y1, and x2, y2. So the change in y would be y2 over y2 minus y1, that's the rise. And then the run would be x2 minus x1. But we could also use these points, and you can see they have have little quotes there. So we could say this is a different x1, y1, a different x2, y2. But if we take, and notice they're closer together too than these two. Okay. But if we take the slope, the rise over the run, the y2, we'll say y2 complement minus y1 complement over x2 complement minus x1 complement, we get the same slope. Okay, even though that triangle is a little bit smaller, that rise over run will be the same no matter which 2 points on the line you pick. So it could be any, it could be these two as well. We're going to get that same slope. It could be points that are way far apart. It could be points that are really close together. And the order doesn't matter either. We can switch the order of the points and we'll still get the same slope. Okay, so let's look at a simple example. Let's say we have the points P, which is 2, 1, and Q, which is 8, 5. We don't need to graph them to find the slope. We just, let's say this is x1, y1, and this is x2, y2. So m is y2 minus y1, which would be 5 minus 1, over x2 minus x1, which is 8 minus 2. Okay, so 5 minus 1 over 8 minus 2 is 4 over 6, which we reduce to 2/3. Okay. Now what we can say with the slope is that every time we move 3 to the right, we're going to move up 2. Okay? And think of that like a step size. So when you have your slope written as a fraction, you can say, okay, 3, that means we're going to 3 to the right because it's in the denominator, and that means we're going to go up, means we're going to go up 2, that's the numerator, every time we go over 3. So we kind of look at our step like this. We go 3 this way and 2 this way to get from point to point, from, well, not, to get to another point on that line, okay, using 3, 2. We could go 4, 6 as well. We go 6, 4, okay. So here's our line, and you can see here's our run is 6, 1, 2, 3, 4, 5, 6, and our rise is 4. 1, 2, 3, 4. But you can see if we go across 3 and up 2, we end up on the line again at a different point. And if we do it again, we get to that second point, across 3 up 2. Okay? And we can actually use the slope to generate points on the line by doing that, by going, run, rise, run, rise. And we can keep going, and we'll get another point in that line. Okay, the next thing we'll talk about is point-slope form of the equation of the line, which looks like this. But let's talk about where that comes from. We start with our formula for slope, okay? And then what we can do is simplify, get rid of our denominator. So I'm going to actually do step 2 first. Multiply both sides by x2 minus x1, okay? And when you do that, you get this, y2 minus y1 equals m times x2 minus x1, just taking this and getting rid of your denominator by multiplying both sides by that common denominator. Okay, so we get this form, and then we'll do step 1. Sorry, I had those backwards. Make that second point any point on the line. In other words, we're going to make it a variable. So it's not going to be some particular point, x2, y2. It's going to be y and x that can vary. They'll be variables. And when we do that, we get this. Now we don't have y2 here, we have y, and we don't have x2 here, we have x. Those are the variables in our equation. So that's how we get that point-slope form. Okay. The nice thing about this form is that you can just put in a point that you have and put in your slope, and bingo, you have an equation of the line. Okay. So all you need is a point and a slope, the slope and one point to get the equation of your line using this form. Okay. But recognize that it comes from the formula for slope. Okay, and setting that second point equal to a variable. Okay, so here's an example. We want to find an equation of the line through 1 minus 3 and a slope of minus 1/2. So we just use that point-slope form. Okay, so we have y minus y1 equals m times x minus x1. Okay, so our y1 is minus 3, so we're going to say y minus y1 is y plus 3. And then x1 is 1. So we're going to take x minus 1, and there's our slope. So there's our point slope form. If we want to get it into general form, we would want to get 0 on one side. So we have to distribute the minus 1/2 x, and here they also multiply both sides by 2. So we have 2y plus 6 equals minus x plus 1, because now you're just multiplying times minus 1 there. So this comes about from multiplying both sides by 2 and distributing, okay, and then just getting the x, the minus x, and the 1 over here to get x plus 2y plus 5 equals 0. So this is just doing algebra to get 0 on one side. That's a general form of this equation of the line. Not very useful, and generally we're not going to put it in that form, but that's the general form, is that you just have 0 on one side. Okay, our slope of minus 1/2 tells us this. Okay, if you write it as a fraction, which it is already, that means as you go 2 to the right, you're going to go down 1 because they have the negative there. So you can see if we go from 1 minus 3, if we go 2 to the right, down 1, 2 to the right, down 1, okay, etc. And we can also go backwards. Okay, we could go 2 to the left and up 1, and that's if we wrote our slope like this. Okay. Put the negative on the bottom, which is generally we don't do, but for slope it can make sense. That makes 2 to the left, and that's up 1. Okay, so we can also go backwards with this. We can say, okay, here's a point, go 2 to the left and up 1, 2 to the left and up 1. You see we still end up on the line there. Okay, so that's just another way of looking at it. But these both, notice, are the same. The slope is minus 1/2 in both cases there. Okay, much more useful form of equation of a line is a slope-intercept form. Okay, and we'll get into this in the next couple slides. But that is y by itself. So we have y equals mx plus b. The m is your slope, x and y are variables, and your b is your y-intercept. It's where the line crosses the y-axis. In other words, where x is 0. Okay, so we talk about slope-intercept form, where it means we have y by itself. So y equals mx plus b is called the slope-intercept form. Let me highlight that. Okay. And that simply means that we have y by itself, and then we can see the slope because it's whatever is times x, and then the y-intercept is that whatever is left over plus b. Okay. So it's easy to pick out parts of the line when you have y by itself. Okay. Okay, so let's look at a couple examples. Find the equation of the line with slope 3 and y-intercept -2. That's easy, we just plug in. M is 3, b is -2. Y equals mx plus b form would give us y equals 3x minus 2. There it is, okay. Okay, in part B, find the slope and y-intercept of the line 3y minus 2x equals 1. Now here we're going to have to get y by itself first, okay, and then figure out what the m is, whatever is times the x, and whatever the b is. Okay, so we got to get y by itself in that line. So we have 3y minus 2x equals 1. Add 2x to both sides, and we get 3y equals 2x plus 1. And then we're going to divide both sides by 3, get y by itself. So y is 2/3 x divided by 3 plus 1/3 divided by 3. So here we can see that m is our 2/3, y equals mx plus b form, and our b is 1/3. Okay, y-intercept. Okay, vertical lines are lines that go straight up and down. Remember that slope is undefined because we don't have a change in x. But it's going to look like this. X equals a is going to be the form. So we could say like x equals 3 is a vertical line. X equals -1 is a vertical line. Now, we don't have a y because we're saying y can be whatever it wants. So when you don't see the y there, it means there's no restrictions on y. So as we go to x equals 3, we're going to go straight up and down forever. When we go to x equals -1, we'll go straight up and down. So there's no restrictions on y. Okay. For a horizontal line, you're going to have y equals some constant. Okay. That means the slope is 0, so m is 0, which means there is no x. Okay. That means that line goes forever back and forth. Okay. When you have y equals some constant. Okay. So there is no x because there's no restrictions on x. Okay. Now y equals 0 would just be the x-axis. Okay. Y equals 2 would be the line that goes through y equals 2 and is horizontal. Okay, so let's look at an example. An equation of the vertical line through 3, 5 is just x equals 3. So there's, we're going to use x as some constant, and x always has to be 3. The graph of the equation x equals 3 is a vertical line, okay, with x-intercept 3. So it's going to cross the x-axis at 3. Okay. An equation for the horizontal line through 8 minus 2 is going to be now horizontal, so we're going to use y. Y is -2. Okay. So the graph of that equation is a horizontal line with a y-intercept of -2. Okay. So here's x equals 3 is a vertical line. You can see it has an x-intercept of 3, but it just keeps going straight up and down. We would have arrows here going in both directions for both of these lines because they go on forever. Okay. So there's our vertical line x equals 3, and here's our horizontal line y equals -2. Okay. So when we talk about a linear equation, we're talking about this form: ax plus by plus c equals 0. In other words, you're going to have an x term, maybe. You're going to have a y term, maybe. You might have a constant term. A, b, and c are constants, so we can say those are real numbers. And basically, this is our general form. We just have 0 on one side. So there's going to be something times x plus something times y, maybe plus something else equals 0. Okay. So this is not a very useful form because it doesn't tell us much about the line. Unlike, the slope-intercept form tells us the slope and the y-intercept. Okay. Point-slope form tells us the point and the slope. Okay. Okay, so this is the general equation of a line. Ax plus by plus c equals 0. Now we can say a could be 0, but they can't both be 0. So a or b could be 0, but they can't both be, because then we don't have an x or a y. So one of these can be 0, but they can't both be. Okay. And we can say every line is the graph of a linear equation, and we can say the graph of every linear equation is a line. So when you graph this, you're going to get a line. When you look at a line, it's going to form this sort of equation where this is true. A and b not both 0. Okay, so let's look at an example. Sketch the graph of 2x minus 3y minus 12 equals 0. Here, we know it's a line. We need to find more than 2 points, though, because if you find 2 points and one of them is wrong, your line is completely wrong except for 1 point. So you want to find at least 3 points. But we can start by saying, okay, let's find the x-intercept. So let y equals 0 and solve for x. So when y is 0, that 3y goes away, and we get 2x minus 12 equals 0. That gives us x equals 6. So we have 6, 0 as 1 point. Okay. And our y-intercept, we're going to set x equal to 0 and solve. Okay, so when x is 0, this 2x disappears. We have minus 3y minus 12 equals 0, and that gives us y equals minus 4. Okay, so our next point using the y-intercept would be 0 minus 4. So we've got 2 points. We just need to plug in and find one more. So let's try one more point. Let's try y equals minus 2, and I picked that because when you do that, you get an integer for x. So when I plug in minus 2 for y, I get 2x minus 3 times a minus 2 minus 12 equals 0. This becomes a plus 6, minus 3 minus 2, minus 12. So that gives me 2x equals 6, okay, because I move this to the other side. Okay. And divide both sides by 2, I get x equals 3. So that would be my third point, is 3 minus 2. Okay. So I got 3 points. My x-intercept, 6, 0. My y-intercept, 0 minus 4, and then a point that I plugged in, 3 minus 2. You should always do at least 3 points for a line. Now they don't show that point here, but if we do minus 2 for y, it would be 3 minus 2 is there. Okay, so we'll put that point in there. So 3 minus 2 is about here. Okay. So there's our other point. Okay. So we got our 3 points, our y-intercept, our x-intercept, and that point that we plugged in, 3 minus 2. Okay. Now, it can be easier, that is plotting points using our intercept method, but we can write the equation in slope-intercept form by getting y by itself. So here's our general form. We're going to add 12 to both sides. Then we're going to subtract 2x on both sides, so we get minus 3y equals minus 2x plus 12. And then we divide both sides by minus 3. Okay, so that gives us a y here, gives us a plus 2/3 x here, and a minus 4 there. Okay, so our slope is, this m is 2/3, our y-intercept is minus 4. So what we can do now, rather than plug in points, is plot that y-intercept, 0 minus 4, and then use our slope of 2/3, remember m is 2/3, okay, which means we go 3 to the right and up 2 to get more points. So when we do that, we can say, okay, here's our y-intercept, 0 minus 4, which was given once we got it in slope-intercept form. Then move 3 to the right and up 2 to get another point. Do it again. 3 to the right, up 2 gives us that x-intercept, right? And then we go backwards by going negative, negative. So we can go 3 to the left and down 2, and that gives us other points too. So remember, we can also write our slope like this. Minus 2 or minus 3, which is the same as 2/3, and that means we're going to go 3 to the left and down 2. So we can go backwards to plot points too. We can go to the left. So if we go 3 to the left and down 2, we still end up on that line, okay? Because this is the same. Minus 2 over minus 3 is the same as plus 2 over plus 3. Okay, parallel lines have the same slope. Okay, so two non-vertical lines are parallel if and only if they have the same slope. So we can think parallel lines never intersect. Okay, so if we have two lines like this, let's say this line has slope 1, m1, and this line slope has m2, then we say that those are the same. Okay, and you think they have the same steepness. Okay, let's do another one like this. Okay, let's say this one's negative slope. These are positive slopes over here, and they're negative slopes here. Okay, so let's say we have two lines parallel going this way. Okay, here's m1 and here's m2. Okay, the slopes will be the same. In other words, the step size going from point to point will be the same in each of those lines. Okay, so the slopes will be the same for parallel lines. Okay, so let's look at an example here. Let's find the equation of the line through the point 5, 2 that is parallel to the line 4x plus 6y plus 5 equals 0. So let's identify these lines so we can figure out which line is which. So we're trying to find the equation of the line through this point. So let's label that L1. Okay, I'll just use cursive L1 there. And parallel to the line L2. Okay, so what we're trying to find is this line that goes through this point. We don't know what it is, and it's parallel to this line. Okay, so we're going to take this line, this L2, and get y by itself. Okay, and we do that. We get y equals minus 2/3 x minus 5/6. So our slope, that's what we're looking for, is minus 2/3. Okay, which means the slope of this one has to be minus 2/3 of L1. Okay, and that's what we're looking for. So we've got a point, and now we have the slope. So if M2 is minus 2/3, then M1, the slope of the first line, is also minus 2/3 because they're parallel, so they'll be the same there. Okay. So now for line 1, we have the slope and a point. We can use our point slope form to find the equation of the line. So we have slope equals minus 2/3 for line 1. We have 0.52, so y minus y1 is 2, equals minus 2/3 times x minus 5. There should be a parentheses there. All right. So, and then we want to put the equation in, I think they want it in general form here, so we would have to distribute here and get 0 on one side. So distributing there, we get, multiply both sides by 3, we get 3y minus 6 equals minus 2x plus 10, remember, because a negative times a negative. Okay. And then if we move everything over to the other side, we get 2x plus 3y minus 16 equals 0. Okay. So there's the equation of our line. For line 1. Generally, when we do these, I'll ask you to put them in slope-intercept form, because I won't ask for general form because I don't think it's very useful. Okay, perpendicular lines are lines that cross at a 90-degree angle. Okay, their slopes are negative reciprocals of each other. So what we do is we flip one slope and change the sign to get the other one. Okay. So negative 1 over M1, M2 is negative 1 over M1. Okay. So here's what our perpendicular lines look like. Let's say we have a line that goes like this, and we call this M1, okay, for line 1. And then we have a line that goes like this, and we'll call that line 2, and there's our slope for that. Okay. That little corner here means they cross at 90-degree angles. So these are perpendicular lines. They cross at a 90-degree angle. Okay. So the slope for one is the negative reciprocal of the slope for the other. Okay. So let's say this slope is 2/3. Okay. Then this slope, M1, will be the reciprocal, change the sign, so minus 3/2. That's a minus there. Okay. All right. Okay, let's look at examples. So show that the points P33, Q817, and R115 are the vertices of a right triangle. We don't need to graph these. We will look at a diagram of this in the next slide, but kind of think we want to see the slopes of two of these line segments are reciprocals of each other, negative reciprocals, so that they're perpendicular, because when we have perpendicular line segments, PR and RQ, then we have a right angle, which means we have a right triangle if they're all connected. Okay, so we're going to take the slope of PR and the slope of QR, okay, and see if they're negative reciprocals. So M1, that would be this PR, okay, that would be 5 minus 3, so change in Y, over 11 minus 3, change in X for PR. Okay, so 5 minus 3 is 2, 11 minus 3 is 8, and that reduces to 1/4. Okay, now let's look at QR. Okay, QR, we would say 5 minus 17 is our change in Y, so minus 12. And then 11 minus 8 is our change in X. So minus 12 over 3 is minus 4. Okay, and we can see that these two slopes are negative reciprocals of each other. If I take reciprocal of this, I get 4, and change the sign, I get minus 4. So we can say that these two line segments here are perpendicular. Okay, and then if you connect the other 2 points, you get a right triangle. So if we actually plot those points, here's what you'll get. I didn't quite have it oriented the exact same way, but here's our PR, here's our QR, and here's our PQ. So we made sure that the slope of this was a negative reciprocal of the slope of that, RQ. And then if we do that, then we have a right angle, because they, remember, negative reciprocal slopes are perpendicular lines, and perpendicular lines cross at that right angle. Okay, a lot of times we use slope as a rate of change. We interpret slope as a rate of change. When we're looking at modeling with linear equations, we're going to look at application problems that have a linear relationship. So we talk about the slope of the line, we talk about that as a rate of change, okay, of one quantity with respect to the other. Okay. So here, like for this example, we can see a tank is being filled at 2 gallons per minute. The slope of the line is 2 because every minute that goes by, okay, the volume goes up by 2. So think about that. If you go, we go 1 minute, we start with 0, and you go to 1 minute and you end up at 2. You go another minute, you end up at 4. You go another minute, you end up at 6. So it doesn't, the scale's a little bit different here, but every time you go across 1 on the x minutes, you're going up 2 on the y, okay? So we can say that we're filling this thing at 2 gallons per minute. So there's our rate, and that's our slope, okay? We can write it like this. M equals 2 over 1, or 2 gallons in 1 minute. Okay, and we can see, so if we go to this one, as 3 minutes go by, we're going to go up 6 gallons. Okay, so that would 6 divided by 3 is 2, right? Change in y over change in x is 2. That gives us our slope of 2 over 1. So we call this a rate of change. How is that volume of the gas changing? Okay, it's changing at a rate of 2 gallons per minute. So we can see 6 gallons in 3 minutes is 2 gallons per 1 minute. Okay, so the slope is the rate at which the tank is being filled, which is 2 gallons per minute. Okay, let's look at an example where our tank is being drained. We have volume of the gas that's starting at 18, and as we go further in time, it's going down, so we're draining it. Okay, so our rate of draining at 0.03 gallons per minute is going to be a negative slope because we're decreasing the volume of the gas in the tank as time goes by. Okay, so we can say slope is minus 0.03, which is minus 0.03 gallons in 1 minute. Okay, if you go 100 minutes, you would multiply this times 100, 0.03, so it'd be minus 3 gallons in 100 minutes. Okay, we're using more here because notice a lot of time is going by here. It's harder to see 1 here, but when you go across 1, you're just going to go down 0.03. Okay, so that's what that slope, as we wrote, is a rate of gallons per minute. It'd be minus 0.03 gallons per minute. Okay. Okay, let's look at an example. A dam is built on a river to create a reservoir, and the water level in the reservoir is given by this equation. Now we can think of this as like our x, t, and w is like our y. So t is the number of years since the dam was constructed, and w is the measurement in feet of the water level. Okay, so let's sketch a graph. So we can use our slope to do that. We could write this as 9/2 instead of 4.5. And also, what do the slope and w-intercept, because we're using w instead of y, of this graph represent? Okay, so our equation is linear. This graph is a line. We should plot 2 points, okay, and draw a line through them. We should plot 3 points. I mean, not 2. Okay, so let's start when t is 0. Our water level is 4.5 times 0 plus 28, so that's just 28. So 0, 28 is on the line. When t is 2, I have 4.5 times 2 plus 28 is 37. So there's 2 points. And let's do a third point. So let's do t is 4. Okay. W equals 4.5 times 4 plus 28, which would be, we're going to add another 9 here. So that would be 46. So that would be 446 would be another point. It's a good idea to have 3 points at least for a line. Okay, 2 is not sufficient. Okay, so here's our graph. We can see the y-intercept is 28 there. Okay, we're going by tens here, so 10, 20, 30. And then 4.5t, you can think of like every time you go across 9, you're going up 2. Since our slope is 4.5, we could write it as 9/2, okay? Which means as you go 2 to the right, you go up 9, okay? So you can say that for every 2 years that goes by, the water level goes up 9 feet, or we can say it goes up 4.5 feet per 1 year, okay? So if you go across 1, you go up 4.5, you go across 2, you go up 9. So the slope is m equals 4.5 represents the rate of change of water level with respect to time. So this means that the water level increases 4.5 feet per year. We're talking about slope, m equals 4.5. This means that the water level increases 4.5 feet per year. Okay. The y-intercept is 28 when t is 0. So the y-intercept represents the water level when the dam was constructed, when time was 0. Okay, and that should be a y there. So y-intercept. Sorry about that. Okay, so that's it for section 110. We will include this on test 2 since we didn't cover it in test 1.